notes for this. We're gonna go to 8.2 notes. And 8.2 is all about adding, subtracting, and multiplying matrices. So it has adding and subtracting and multiplying in this section. Add, subtract, and multiply matrices. Okay, so when you did your bell ringer today on IXL, I told you to just try some, like the addition, kind of easy addition ones. And those weren't too bad, the add and subtract. So the thing about the addition of matrices and subtraction, add and subtract matrices, the thing about it is they have to be the same dimensions. Like the same size for you to be able to add and subtract. Two matrices, if you're going to add and subtract them, they have to be the same dimensions, or you can't do it. Like if I tried to add a matrix like this, 1, 3, plus, and then if I had a matrix like this, 1, 2, 3, 4, I'm just using easy numbers, you can't do that one. They're not the same size. They have to like match up, like you have to add like the top corner of this matrix plus the top corner of that one. There would have to be a number here so I could add it to the bottom corner of that one. You can't do this one. They have to be the same size. Dimension is size. So this one, can't do it. Can't do this one. Just wanted to point that out. You're not always going to be able to do them. So they would say like undefined. Can't do this one. Like no solution. They put like a 0 with a slash through it. Can't do this one. Okay, but we'll try a different one. I'll show you something, just want to show you like, yeah, sometimes you can't do it. All right, so let's try something like this. I'll try matrix A equals, and I'll just put 2, 1, -3, 0. And now I'm going to put matrix B equals 3, -5, 1, and a 2. There, that's good. Just a couple numbers here. Okay, so this time I'm saying this one's called matrix A, and here's another matrix of numbers. This one's called matrix B. They're going to do some questions where they ask you to find something like this, 3A minus B. Let's try something like that. Find 3A minus B. So what do you think the 3 means to do? 3A. What do you think we're going to do? So 3 is, if it's 3A, it's 3 times A. So we want to do 3 times matrix A.
Multiply matrix by 3.
Yeah, exactly. Multiply matrix by 3. So we're going to do 3 times matrix A minus the matrix B. I'm just going to copy down what matrix B is. Okay, so I know you guys have heard of the distributive property before. This is the distributive property. You're going to have to do 3 times matrix A. You have to multiply everything in matrix A by 3. Everything. Like distribute that in times everything in matrix A by 3. So it's distribute. So it's kind of weird because it's like 4 things in there times everything in there by 3. All right, so let's do that. 3 times 2, that's 6. 3 times 1 is 3. 3 times negative 3, that's negative 9. And this one's 0. And I didn't do anything to the other matrix. It was just 3 times A. So I didn't have to do anything to the other matrix. Okay, now we should be able to finish it off. We took 3 times matrix A. Now you should be able to finish and subtract now minus matrix B. And like I was saying earlier, it's kind of like just since they're the same size, you can do it. The numbers in these top corners are going to go together. I'm trying to use some colors. Like here is a light blue. I'm just kind of circling these. See, like I could subtract 6 minus 3. So let's see, 6 minus 3, that'd be 3, correct? And it's pretty easy so far. And here I'll use a different color, like this one here. I'll put green around it. This one and this one go together, right? See, it's just knowing that you're doing the same locations, like the top corner. So 3 minus negative 5, that'd be like 3 plus 5. That'd be 8. Then we got this negative 9 down here in the bottom corner. Negative 9 minus 1, that'd be negative 10. And then finally 0 and this 2, see in that corner? See, I'm just trying to color code it so you see it's just the same locations. 0 minus 2, that'd be negative 2. So hopefully that's pretty straightforward. Do you have any questions about that? Feel free to type in the chat if you're saying, wait, where'd you get this from? See, just this one, top corner minus this one. So hopefully pretty easy. Okay, then there's some properties. Well, that's the distributive property. I just already showed you one of the properties, and you can see how you can distribute things. So the distributive property applies with matrices. There's some other properties, the commutative property that work with matrices. And without going into this too much, it should make sense. They say that if you add like matrix A plus matrix B, it's the same as if you put B first and then added A. It's pretty obvious that if you add, I could do a quick example of it, like if you had the matrix 1, 2, like that, plus, and I'll just use 3, 4, just because it's easy. If I add matrix 1, 2, plus the other matrix that says 3, 4, do you think that's the same answer as if you put 3, 4 first, and then added matrix 1, 2? The commutative property says that if you switch the order of these, you should get the same answer. Hopefully that makes sense. Like 5 plus 2 is the same as 2 plus 5. You can switch order of things. Because this comes up when we get to testing on this unit. They want to know if you understand that these properties work. They want you to understand literally that if you switch the order of adding these things, it's still the same. It does come up on the test. Commutative property, you should know that that does work. See, if I add like 1 and 3, I get 4. And if I add the 2 and the 4, I get 6. Well, that's the same as if I went over here and added the 3 first, then the 1. 3 and 1, that's 4. 4 plus 2, that's 6. So you get the same answer if you switch the order of the matrices for adding. So you should know that commutative property works. Another property that works is called the associative property. And you guys, we showed distributive property works, so you can use the distributive property with these things too. So the associative property, that also works with these matrices. And this one just kind of groups it different. Like if I had matrix A plus a matrix B and a matrix C, if I'm adding, they're saying like if I add these two first with parentheses, you do parentheses first. If I add these first and then add matrix A, I'll get an answer. It should be the same as if you would add A and B first and then add matrix C. So I don't know if I need to do a whole nother example again, but it's just like kind of the same thing as like the order you add things in doesn't matter. See, like the order you add things in, it doesn't matter. You should get the same answer. It's the same with the associative property. The order you add these matrices in shouldn't matter. We should get the same answer. If I add, you know, it's the same concept. If I added just something basic, not even a matrix. If I added 3 plus 5 plus 1, if I add the 5 and the 1 first, I get 6, and then add the 3, then I get 9. But if I would change the order and say, well, add 3 and 5 first, and then the 1, well, 3 plus 5, if I did that one first, that's 8, and then add the 1, I still end up with 9. See, the whole point is the order you add things in doesn't matter. So you should just know, even if I wrote matrices down and numbers in the matrices, if I added the last two matrices first and then this one to it, it would be the same as if I add matrix A and B first, then matrix C. So you just have to know the associative property works. It works. Without going into a big, huge example. Okay. So yeah, it's just like kind of, again, showing you like, yes, we can distribute with matrices like we did here. We can add matrices and switch the order and we'll get the same answer. That's showing you the commutative and the associative property work. Yep, they work. Like switching the order of them doesn't matter when you add. But now let's get to multiplication. This is the hard part that we would have to get to. Okay, matrix multiplication. This is a different kind of monster. It's a little different. Okay, so we're gonna try and show you a matrix multiplication. Like I said, this is different than adding and subtracting. Just a few minutes ago we were doing some adding. When we were doing adding and subtracting, the matrices had to be the same size, I was telling you. But with multiplication, it's a little different. So let me find one. Let's see if there's like an easy example. Well, I'll do this one. This one's not too bad. Okay, so I'm going to write a matrix down. -1, 3, 4, -2, 5, 0. And then we're going to try to multiply it by another matrix that says -3, 2, -4, 1. All right, matrix multiplication, it's a little different. Last time we were talking about rows and columns, how many rows and how many columns these matrices have. So rows go side to side, columns go up and down. So this first matrix I wrote down, you can see that it has 3 rows, 1, 2, 3, 3 rows, and up and down has 2 columns, right? So it's a 3 by 2 matrix. It's a 3 by 2 matrix. Well, the other matrix over here has 2 rows side to side, 2 rows, and 2 columns. And when you write these things down, you do have to write rows first. That's what I was kind of pointing out. We have to write the side to side rows number first, then the columns. Okay, you have to, when you're doing matrix multiplication, you need to think of the sizes of these matrices. And the thing is, they don't have to be the exact same size for you to be able to multiply. Adding and subtracting, they have to be the same size, but not on multiplying. They don't have to be the exact same size. But you have to check them to be able to see if you can do them. It's actually kind of interesting. It's that this column number has to match this row number. These match, so I can do it. So you have to write the sizes down and then kind of look at the inner numbers, the ones, if these match, you can do it. It's kind of weird. Rows and columns, rows and columns. And if the column number matches this row number, then I'm like, okay, I can do this problem. And what's interesting is then you're going to be like, well, how big is my answer going to be? My answer, I'll just do it in blue, is going to be a 3 by 2 matrix. The outer numbers tell you what size your answer is going to be. So if these match, that means we can do it. We can go ahead and multiply these. It means we can do this problem. And this these outer ones, it predicts or tells you the size of the answer. My answer is going to be a 3 by 2 matrix that I'm going to put over here, the answer over here. It's going to be a 3 by 2. All right, so now let's get to it and show you how to do this. I brought some colored pencils today because it's kind of tricky. All right, so to do matrix multiplication, you have to take the rows. You have to do the rows over here. You have to take rows times columns. Matrix multiplication. Let's see. Yeah, you have to take the rows times columns in the other one. I'm trying to write it up here at the top. Rows times columns. So I'll use colors. I'll try to use colors. So I'm saying you're going to have to take this row that I'm highlighting in green here, circling in green. You're going to have to take that row times this column in this one. All right, so let's show you how this works. I usually just kind of use my fingers and point to show you. You have to take the first number here times this number. It's multiplication, so it's times. You times these, and then you move your finger over and down, and you times these, and then you add that together. So it's kind of tricky. It's kind of tricky to explain. You times these, so let's try it. What's -1 times -3? That's 3, right? 3, and then if I times this, I get -12. So it'll be 3 plus -12. So I'll write it here. It'll be 3 plus -12. And whatever and then I'll have to add that up and I could put the final answer. So I usually kind of point when I'm doing them. 3 plus -12, that would be -9. Right? I'll write what I did up here, and then that's the answer. This is final answer here. This is like showing my work. What do you think? So you have to do this times this, move your finger over and down, this one times this one, add it up. I know, it's hard. Okay, now I'll use another color. I'll use this brown kind of. Now we use the same row, the green row, times this second column. So now we're doing it again. I'll write it over here. We're going to do this top row times the second column. So it's going to be this times this. It'll be -2, and then times, see where I'm pointing? This times this, that's 3. So it'll be -2 plus 3. -2 plus 3. -2 plus 3. See, this one times this one, plus this times this. Okay, so -2 plus 3, that's 1. And I'm trying to repeat myself and say it a couple times. So, but if I'm going too fast, let us know, like on the chat. Be like, wait, whoa, how'd you get that or something? Let us know, because I know this is tough. Okay, so now I'm done with row 1, because I did row 1 times each of the columns. I did row 1 times column 1, and then I did row 1 times column 2. So now I need to move down and do row 2 now. Row 2 times each of the columns. So I'm circling in orange. So I'm going to do orange and blue, and then orange and this brown. Weird, huh? I'm trying to take my time and explain it to you guys really good. Yeah, let us know in the chat if you're like confused, and I can try to slow up and say it again. So now we're doing this orange row times this blue column. So again, I try to point at it with my fingers here. I'm going to times this 4 and this negative 3. So that's negative 12. Plus, what do I get when I times these? That'd be 8, right? Negative 2 times negative 4, that's 8. So negative 12, so plus 8. So negative 12, and that turns to 8. So negative 12 plus 8. So that's negative 4. Hopefully they can see it okay. I'm trying to line it up. Okay, now I'm on the orange row still. Orange row, now with this brown column. So this would be 8 plus negative 2. See how that worked? 8, 4 times 2 is 8. Move over and down. This one times this one, that's negative 2. So see how I'm trying to like move my fingers? This and then this. Weird, isn't it? 8 plus negative 2, that's 6. All right, we're getting to the end. Let's try a dark color here. No, it's not that dark enough. I need a different color. It's okay. I'll do blue again. So it's a blue times blue, but it's all right. So now the blue row at the bottom times this first blue column. So what do you think? Type in the chat, what do you think you're going to put for this one? You can tell me like something plus something. See if you can figure it out in the chat. For this blue row times this blue column, what's it going to say? Let's see if they know it. Row times column. Do you know what it's gonna? What I'm gonna put here? They're thinking. I know it's hard because you guys aren't right here in front of me. What do you think?
15 plus 0. I have
A couple of you guys are typing now. There we go. 5 times the negative 3. Yep. Good job. And then, yep. And then this part will be a 0 because 0 times. Good job. You got it. Awesome. Yep. Negative 15. And then plus this would be 0. Yep. This 0 times this. Good job. You got it. All right, and then the last one is this blue row still times the second column. So this would be, let's see, 5 times 2, that'd be 10 plus 0. Do you see that? 10 plus 0. 10 plus 0, that'd be 10. So I wrote like the plus here so you can see how I got each one, and then yep, this is the final answer. Just added them up. It is weird. The matrix multiplication takes some practice. It takes some getting used to. Okay, so we'll try, I'm going to write one more of these to get you guys thinking about it. Let's look at this one. So 3, I'll write a matrix down. 7, 0, negative 2. And then 6, 4, 2, negative 1. Okay, so here's another one. Okay, so like I said at first, you do need to think of the sizes of the matrices. And like look at this one we got it, and we did get a 3-row, 2-column matrix at the end. So like the blue, you know, the sizes, you have to think of the sizes. So let's write down what sizes you think these are, these matrices. And then we'll try to see like what size is the answer matrix going to be. So think about it for a minute. See if you can think about what size is this matrix, what size is this matrix. Sizes always go rows by columns. Row
2 by 3 and then
times
2 by 2.
Okay, good. Good, you guys are catching on. So you always have to do the rows first. Rows go side to side. Rows are on the out edge. So yeah, this has 2 rows. And this one has 1, 2, 3 columns. Good job. This is a 2 by 3. And this one, you said 2 by 2. Good. So now let's look at that. You have to look at the inner, like the ones closest together. Do these match? Obviously no. So guess what? We can't do this problem. If these don't match, you can't do the problem. So what you just say is undefined, or put a 0 with a slash. You can't do this one. These don't match. So you can't do it, so it's called undefined. You can write the word undefined, or you can write this 0 with a slash through it. I'm not sure what WebAssign says. It might tell you to type undefined. It probably tells you to type undefined, because I don't think they have that symbol. They might, I'm not sure. Yeah, if it doesn't work, they'll tell you, like if not possible, right? Or they might have you write not possible. Yeah, they might have you write the words not possible. I think they do say that. I remember looking at the WebAssign. They might literally tell you to type the words not possible. Okay, so that one you can't do it. Okay, I'm going to show you one more, and then I think we basically have it covered, this matrix multiplication. I know it's kind of tricky. That's why I'm trying to do a couple of them. Okay, this one, let's try this one. This one's kind of different. Let's do that, this one. All right, so I wrote a tall column 1, 2, -1, 1, and then this matrix 1, -2, -3. So again, let's think of the sizes of these things. Think of the sizes of these matrices. All right, so again, you have to look at the rows on the sides first. How many rows does this thing have? Obviously 3. 1, 2, 3. And then you only have 1 column here. So this is a 3 by 1 matrix. 3 by 1. Well, what's this other matrix? Only 1 row. Only 1 row going side to side. 1 row, and it has 1, 2, 3 little columns. So can we do this one? And what size is our answer going to be? If we can do this one, what size is the answer matrix going to be?
Yes, we can do it, and it's going to be 3 by 3.
Yeah, it's weird. Yes, we can do it, even though this was like little skinny ones. Yes, we're going to be able to do it because these match. Good job. And the answer matrix, which is weird, which you're going to be kind of mind blown here, the answer is going to be 3 by 3. And you're like, whoa. The answer is going to be kind of a big matrix, a 3 by 3. So a 3 by 3, ooh, I need to make a big square, a big space for that. Yeah, my answer is going to be a 3 by 3 over here, which means I have like 3 rows and 3 columns. So I need to fill in like all these spaces. I'll put little dashes, like I have 3 rows and 3 columns to fill up with all these numbers. So this was kind of weird. Sometimes people have trouble with these just because they look kind of funny. So this has 1 row. So we're going to start with this top row, and it only has this 1 number in it. And you're going to times it by the first column over here. So you can see this time I'm not gonna have to like slide my fingers around and add things. It's kind of a weird one. You're just gonna have to take this top row number times this column 1. So it's just 2 times 1. Okay, well, 2 times 1 is 2. So my first answer is a 2. This one's, you might find it simpler because you don't have to add stuff. You don't have to like move your hands across and like I did that other one. Yeah, it's just this times this. So that's 2. So now try to realize you have to stay on this top row until you've done all the columns with it. So now I'm still on top row, now I just go to the next column. So now I'm like on this top row and go into this blue one I circled. So this times this, that's -4. And hopefully you kind of will catch on here. And I'm still on the top row, so you have to stay on the same row until you've done all the columns with it. So still on top row, last number, so that'd be -6. So I did row 1 with each column, filled in my top. Now I'm going to do row 2 with each of these columns and fill in the middle section. So what do you think? You kind of catch on? I'll keep going. So now I'm on the second row. Let's try a different. This row with column 1. Row 2, column 1. So that'd be -1. -1 times -2 right here. Negative times a negative turns to positive, so that'd be a 2. This row times this column, that'd be a 3. Negative times negative again, so it turned to positive, 3. And finally, the bottom row times each column. Oh, this will be easy. It's 1 times each thing. So 1 times 1 is 1. 1 times -2 is -2. 1 times -3 is -3. 1 times that, 1 times that, 1 times that. And this is the answer over here. All right, so hopefully you'll got the idea of matrix multiplication. Not too bad. The assignment's on a WebAssign again, and it's worth mentioning that they want you to figure out the sizes, like I said, like, oh, like what size was this answer going to be, 3 by 3? And yeah, it might start out on WebAssign with just like a small matrix, but they have like arrows on the side on WebAssign, and you can adjust the sizes of your matrix on WebAssign. You can adjust the matrix sizes on WebAssign. You'll see when you get there, you're going to get to a problem, you're going to be like, okay, I need to type my answer. Oh, I need a bigger box to make my answer fill in. So you can adjust the matrix sizes on WebAssign. There's like an arrow on the side you can click. It's like you can click the line right here and move it out or in. You can make it have more rows at the bottom too. There's a thing on WebAssign you can click. I'll go over to one of those and show you, because I know I'm sharing my screen here. I'll just have to go into WebAssign and screen from there. Let's see here. You go to WebAssign.